Hey guys, welcome back. We have been working on different digital sensors, and today I'm going to start working on a new digital sensor that's TSL2571. Now to explain more about this sensor, let's have a look over the website that is controleverything.com, and here search out for the sensor that is TSL2571, and let's see what we got. So we got that TSL2571 is a light to digital converter programmable analog gain. It's a light sensor in short, and as you can see, these are some of its features which you can have a look over. Now you can also have the purchasing power from here. You can add to cart here. I will be interfacing the light sensor TSL2571 with an Arduino Nano, and I will be requiring an Arduino code. So I will go to resource tab, and here comes the Arduino code sample. Now you can download the Arduino code sample as a zip file from here. Also, you can have the opportunity to download the code from GitHub repository, and it's called Control Everything Community. Now, what we require is to connect some hardware and make some connections for the response. This here is our light sensor TSL2571. Now, what we require is an Arduino Nano, which you are able to see on my screen. To make a connection among the sensor and the Arduino Nano, we require an I2C shield, which is available on the website controleverything.com. Now, the reason why we use is to make connections with other I2C devices and rather make that connection a lot easier. So gently place the Arduino Nano over the I2C shield and make a connection. Now, the next part is to make a connection among the sensor and the I2C shield, and here comes a connecting cable into the picture. Now make the connection, and while making a connection among the sensor and the cable, the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly we have to follow this rule for the I2C shield also. Finally, we have to power up our Arduino Nano, and here comes our mini USB cable. Now gently insert it over the power jack and you can power it up. Now we are done with the connections part. For the hardware what we require now is a code so that we can interface, and let me explore the code for you. Along with the Arduino Nano, we require the Arduino code so that we can interface our light sensor TSL2571. So log in to github.com and here explore the repository that is Control Everything Community. Search for it and get it over. Now search for the sensor we are looking forward to explore, that is TSL2571 light sensor, and here comes the Arduino code. But before that, let's have a look over the instructions we need to follow to have this code working. And it says that we have to download and install Arduino software IDE on our local machine, and the steps are being provided on this very link, official link arduino.cc. Let's have a look over this link so that we can have a better viewpoint regarding the installations system. We can download the Arduino software from here, and it runs on the Windows, Mac operating system X and Linux. So as you can see, all the relevant information is provided here. All you need is to install the software, so better get it done. Now get back to the code, and here we go. It's a .in extension file. In the code, as you notice, we have included wire.h library and defined the address of the sensor, that is 0x39. Now in the void setup function, we have initialized I2C communication as master along with I2C serial communication with the baud rate equal to 9600. Now comes the writing part. But before moving to the writing part, let me tell you that 0x80 is the command register, and we are in an OR condition with writing this commands. So let it done. So first of all, we have to select enable register having command 0x00 or with command register 0x80. Then we are sending the command to set power on ALS enabled, and it's 0x01. Then we have to select enable register, and the command for that is 0x00 or with command register 0x80. The command we send here is set power on ALS enabled, and the command is 0x0. And now we are selecting the address of the register ALS time register having address 0x01 or with command register 0x80. The command we are sending here is A time equal to 2.72 ms, max count equal to 1023, and address is 0xff. Then we have to select the wait time register having address 0x03 or with command register 0x80, and we are sending the command to w time equal to 2.72 milliseconds, and 0xff is the part of that. Now finally we are sending the control register having address 0x0f or with command register 0x80, and the gain here is 1x. It comprises 0x20. So we are done with the writing commands. Now we want to have the data back from the sensor which it responds, and we are selecting the data register having address 0x14 or with command register 0x80. We are requesting and reading 4 bytes of luminous data, that is light data, channel 0, channel 1, and we are converting the data. As you can see, the luminous data, we are using a lot of formulas which are being clearly described in the data sheet for TSL2571. Finally, at the very end of our code, we have to display the output data on the serial monitor. It's the ambient light luminance and the unit is lux. Now please note it down carefully and have a clear view regarding the code, and let's have a look over the working of this sensor along with the code. Now for the working part, that's very interesting. We have to show the practicality of this Arduino code. So for that, first of all, copy this entire Arduino code and open up the Arduino terminal here. Now in the Arduino terminal, we have to paste the entire code we have just copied and save it as the name TSL2571 for the reference, and save it. Then verify and compile the code as you can see on my screen. Now it's done. Now upload the code. It might take a while, but let's just wait. It's uploaded. Now we have to check for the output which is to be displayed on the screen, and let's have a look over the serial monitor for that. And we have the ambient light luminance which is in the lux, that's the unit, and it's almost constant. But when I place an object over and cover the light source providing it, as you can see, it's decreasing, and I place this object more near the sensor, it will decrease further. Yeah, just like that. But in case when I am placing a light source near the sensor, you can see the ambient light luminance increasing, and when I close by the sensor near the light source, it will increase further. So this is how the sensor works along with the Arduino code and Arduino Nano. Now what do we require is to have a look over the features and the benefits and the reason why we use this sensor in a lot of applications. The TSL2571 family of devices provide ambient light sensing (ALS) that approximates human eye response to light intensity under a variety of lighting conditions and throughout a variety of attenuation materials. While useful for general purpose lighting sensing, the device is particularly useful for display management and with the purpose of extending battery life and providing optimum viewing in diverse lighting conditions. Now these features make it very useful for applications like display management, backlight control, cell phones, PDA, GPS, notebooks and monitors, LCD, LED TVs, and a lot more. Now you can have the opportunity to purchase the sensor from the website, that's controleverything.com, and you can have the code from resource tab. Now also after that you can download the code from there. Well, you can also have the code from GitHub repository, that's Control Everything Community. Now in the end, I would just like to make it clear that in case you guys are in kind of feeling that you are left without fully understanding, you can have your queries on controleverything.com, and also you can post your comments on the community page of this website. For articles and blogs which are relevant to this video, you can contact us on instructables.com, and to subscribe more video tutorials which are relevant to these videos and tutorials, you can go to YouTube channel. In the end, I hope you enjoyed this video, you have a good time. Thanks for watching.